Electric current. By the end of this lesson, you should be able to state the relationship between electron flow and electric current. Define electric current. This activity shows a simple circuit being set up in the laboratory. Observe the effect of connecting and disconnecting the wire in this circuit. Why does the bulb light up only when the wire is connected? A Van de Graaff generator is a machine for producing large quantity of charges. It can be designed to produce either negatively or positively charged domes. When the Van de Graaff generator is operating, the dome is continually being charged. If there are extra electrons, the dome is negatively charged, and if electrons have been removed from it, the dome is positively charged. Consider a negatively charged dome. What will happen if the dome is connected to an earth point, for example, a metal water pipe, through a galvanometer? Look at the pointer of the meter.
Click on the switch to complete the circuit.
When the Van de Graaff generator is switched on, the pointer of the meter moves. The meter reading is caused by the movement of charge from the dome to earth. When the final connection is made to the battery, the bulb lights up when electric current flows through it. This means that charges are also flowing through the circuit. Observe what is going on in the wire. The wire, like all metals, contains some electrons which are free to move about. Before the connection is made to the battery, the electrons are orbiting around the nucleus and there is no flow of charged particles. When an electromotive force is applied to the metal wire, the charges leave the negative end of the cell and flow along the path of the wire towards the positive end of the cell. Consider a cross-section of the wire. A certain amount of charge passes through the plane every second. Electric current is the rate of flow of charges in a circuit and would be expressed as electric current equals charge over time. Or in the symbols normally used, I equals Q over T. The SI unit for current is the ampere, and the SI unit for charge is the coulomb. Ampere is abbreviated by the unit symbol A and coulomb by the symbol C. Current of 1 ampere means that there is 1 coulomb of charge passing through a point in a wire every second. 1 ampere equals 1 coulomb per second. To measure electric current, an ammeter is used. When a battery is connected in a circuit, charges will flow. Electrons which are negatively charged flow from the negative terminal to the positive terminal of the battery along the circuit. In the circuit diagram, arrowheads indicate conventional current direction. It is a common misconception that the positive charge from the positive terminal of the cell flows to the negative terminal. Thus, arrows on circuit diagrams are often marked in this way. In fact, the real flow of electrons is in the opposite direction, from the negative to the positive terminal. This activity shows how the charges that flow switch on the Van de Graaff generator and touch the ball on one metal plate, then let it go. Why does the ball swing back and forth between the plates?
As the Van de Graaff generator is operated, the dome could be positively charged or negatively charged. Think about it as a negatively charged dome. The negative charge on the Van de Graaff generator goes along the wire conductor, giving the metal plate A a negative charge. The negative charge on plate A induces an equal and opposite positive charge on plate B by forcing negative charges to the earth, leaving positive charges on B. When the ball touches plate A, it receives some negative charge and is immediately repelled by plate B. On touching plate B, the ball loses negative charges and becomes positively charged. The ball is then repelled back towards plate A. Thus, each swing of the ball transfers electric charges between the plates. As the charges are being transferred, the manometer detects the charge flow.